friends, welcome to all of you. This is Professor Dattu Patel from LJ Institute of Engineering and Technology. In this semester, I will teach you Mathematics 1. Earlier lecture, we are already discussed about Taylor series, another form of Taylor series, examples of Maclaurin series and Maclaurin series. Today's session, we discuss about examples of Taylor series. Let's start with one example. Find the Taylor series of x cubed plus 7x squared plus x minus 6 in powers of x minus 1. First of all, that is our function x cubed plus 7x squared plus x minus 6. Then successive derivative of this function means f dash of x equal to 3x squared plus 14x plus 1, again derivative, then we get 6x plus 14, again derivative, then we get 6 and 4 times derivation, then constant, then 0 and so on. Now here in powers of x minus 1, then x minus 1 equal to 0, then we get x equal to 1. That is the position. At this particular position, we will have to find Taylor series. We will substitute x equal to 1 in these equations, that we get f of 1, then 1 plus 7 plus 1 minus 6, then we get 3 f dash of 1, then we get 6 plus 14, then 20 f double dash of 1, sorry, that is f double dash, f dash of 1, that is 3 plus 14 plus 1, that is 18, f triple dash of 1, that is 6, and 4 times derivation of 1, that is 0. By Taylor series, actually our Taylor series is f of x equal to f of a plus x minus a by 1 factorial, f dash of a plus x minus a whole square by 2 factorial, f double dash of a plus x minus a raised to 3 by 3 factorial, f triple dash of a, and so on. Here our position is 1, then that is not a value of x, but that is a position, means f of x, then our Taylor series becomes f of 1 plus x minus 1 f dash of 1 plus x minus 1 whole square by 2 factorial, f double dash of 1 plus x minus 1 raised to 3 by 3 factorial, f triple dash of 1, and so on. Now substitute this value in this equation, then f of 1, that is 3, plus x minus 1 f dash 1, that is 18, plus x minus 1 whole square divided by 2 factorial, that is 2, and double dash, that is 20, plus 3 times differentiation, that is 6, in 6 x minus 1 raised to 3 by 3 into 2, this one is cancelled out, f 4 times derivation, that is 0, 2 tens are, then our Taylor series is 3 plus 18 x minus 1 plus x minus 1 whole square into 10 plus x minus 1 whole cube. Next example is find the Taylor series of log x in powers of x minus 1. Also find the values of log 1.1, here base e. Then first of all, log x, that is our function, derivative of log x, that is 1 upon x, again derivation, that is minus 1 upon x square. Again, then we can write minus x raised to minus 2, then twice x raised to minus, this means 2 by x raised to 3, again derivative, then minus 6 x raised to minus 4 means minus 6 upon x raised to 4, 5 times derivation, then we get 24 upon x raised to 5 and so on. Now substitute the values of x as a 1, because here x minus 1 in powers of x minus 1, then it becomes x equal to 1, then f of 1 equal to log 1, value of log 1 that is 0, here f dash of 1, then 1, f double dash of 1, then minus 1, f triple dash of 1, then we get 2, 4 times differentiation, then we get minus 6, and 5 times derivative term, then we get 24 and so on. Now substituting these all the values in Taylor series, then by Taylor series formula, that is f of x equal to f of a, but here x equal to 1 in power, so that is value of a, that is the position. At this particular position we have to find Taylor series, that we put directly Taylor series f of 1 x minus 1 f dash of 1 x minus 1 whole square by 2 factorial f double dash of 1 x minus 1 raised to 3 by 3 factorial, 3 times differentiation and so on. Now substitute the values of f of 1 f dash 1 f double dash f triple dash f1 and so on, and f of 1 that is 0, 0 into anything 0, here log x, then plus x minus 1 f dash 1 that is 1 plus x minus 1 whole square by 2 factorial, that is 2, means minus 1 x minus 1 raised to 3 by 3 to the 6 into 2 plus x minus 1 raised to 4 by 4 3 2 1 into minus 6 plus x minus 1 raised to 5 by 5 factorial, means 5 4 3 2 1 into 24 and so on. Here 2 cancel out, here 3 to the 6 which is cancel out, 4 3 are 12 2 are 24 which is cancel out. Then our Taylor series is log x equal to x minus 1 minus x minus 1 whole square by 2 x minus 1 whole cube by 3 x minus 1 raised to 4 by 4 x minus 1 raised to 5 by 5 and so on. Here we will find also ln 1.1. To finding this value, to find log 1.1, we have to substitute x equal to 1.1 in equation A. Then in this equation we find 1.1, then 1.1 minus 1, then we get 0.1. Here x minus 1 means 1.1 minus 1, then we get 0.1 minus 0.1 whole square by 2 plus 0.1 raised to 3 by 3 minus 0.1 raised to 4 by 4 plus 0.1 raised to 5 by 5 and so on. Now simplify this term, minus 0.01 divided by 2 means here 5, 0.05 plus 0.000333 and so on. Now adding and subtracting this value, then we get 0.09553, that is the approximate value. You can find directly in Cal C ln 1.1, then we get exactly this value. Next example. Expand the Taylor series of 10x in powers of x minus pi by 4. Also find 1046 degree and 1044 degree. First of all, 10x, that is our function. In this example, we require much more space. That's why, first of all, 10x, that is our function. Derivative of 10x, that is sec square x. Again, derivative, that is 2 sec x into sec x into 10x. Derivative of sec, that is sec x into 10x. Then here we get 2 sec square x into 10x. Now that is the value of u. That is value of v. We will use product rule. Means d by dx of uv, u as it is, derivative of v plus v as it is, derivative of u. And third times differentiation. Then we get u as it is, derivative of v, that is sec square x, plus 10x as it is, 2 2s are 4, sec x into 10x. Then we have sec raised to 4 plus 4 sec square x into 10 square x, and so on. Similarly, we will find up to 4 times derivation, 5 times derivation, and so on. Now, here the in powers of x minus power, x minus pi by 4, then our position, that is pi by 4. Then substitute the values of f of pi by 4, then 10 pi by 4. 10 pi by 4, that is 1, and sec pi by 4, that is root 2. And substitute this value here, then 10 pi by 4 is 1, here f dash of pi by 4, then sec pi by 4, then root 2 whole square, then we get 2 here. F double dash of pi by 4 means twice root 2 whole square into 1, then we get 4. F 3 times differentiation, then we get twice root 2 raised to 4 plus 4 root 2 whole square into 1, then 4 2s are 8 plus 4 2s are 8, then we get 16, and so on. Now by Taylor's series, then substitute this all the values in equation of Taylor series, then f of x equal to f of pi by 4, because our position is pi by 4, plus x minus pi by 4, f dash of pi by 4, plus x minus pi by 4 whole square, f double dash of pi by 4 by 2 factorial, plus x minus pi by 4 raised to 3 by 3 factorial, f 3 times differentiation of pi by 4, and so on. Now substitute this all the values in Taylor series, then f of a function, that is our 10x, f of pi by 4 1, f dash of pi by 4, that is twice whole square by 2 factorial, that is 2 here, f double dash, that is 4, and f triple dash, that is 16, x minus pi by 4 raised to 3 by 3 is 6, and so on. And 2 8s are here, 2 2s are, then we get Maclaurin series of, Taylor series of 10x, that is x minus pi by 4 square, x minus pi by 4 whole square into 2 plus 8 by 3 x minus pi by 4 is to 3 and so on. Here we get Taylor series. In this example, we will find 1046 and 1044. Then to find 1046 degree, then first for here x equal to 46 degree, then we convert degree into radian form. Then we will multiply with pi by 180. Then in scientific calculation, according to our GTU syllabus, we must have 82 ms calculator. Then convert this calculation 46 into pi divided by 180. Then we get 0.80285, and we have pi by 4. Then divide by pi by 4. Then we get 0.78540. Then we have replaced x minus pi by 4, means value of x, that is 0.80285 minus 0.78540. Then subtraction this term. Then we get 0.01745. And substitute this value, that is the value of x minus pi by 4. Substitute this value in Taylor series and simplify the term, then we will get value of 1046. Then here 1046 degree equal to first 1 plus x minus pi by 4, that is 0.0, that is 0.01745 whole square plus twice 0.1745 square plus 8 by 3 0.01745 raised to 3 and so on. Simplify this term in calculator and we will get 1046, that is 1.03553. That is our approximate answer. Similarly, you will find 1044. Then substitute here x equal to 44 into pi by 180. Then whatever the answer, that is subtraction is this. Then we get here negative value. Value is same, but only sign is interchange, and here answer is different. You can try this. Next example is find the Maclaurin series of, find the Taylor series of sin x in powers of x minus pi by 2. Also find sin 91 degree. Similarly 10x, we can find sin x. Then first of all, what is the function? That is our sin x. Then derivative of sin cos x, again derivative, then minus sin x, 3 times differentiation, then minus cos x, 4 times differentiation, minus carry forward, then the minus 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 plus 5 times differentiation, that is cos x, and so on. Here in powers of x minus pi by 2 equal to 0, then that is our position x equal to pi by 2. Then substitute the values of x equal to pi by 2 in this equation, then we get here sin pi by 2, that is 1, and cos pi by 2, that is 0. Then substitute this value in this equation, then we get f of pi by 2, that is 1, f dash pi by 2 0, f double dash of pi by 2 minus 1, triple dash of pi by 2 0, 4 times derivation of pi by 2, that is 1, and 5 times differentiation of pi by 2, that is 0, and so on. These terms will be continue 1 0 minus 1 0 1 0 minus 1 0 1 0 minus 1 0, and so on. Substituting these all the values in Taylor series, but here Taylor series in terms of x minus pi by 4. Then here we position, that is value of a equal to pi by 2. Then we will replace f dash of pi by 2 x minus pi by 2 plus x minus pi by 2 by 2 factorial f double dash of pi by 2 plus x minus pi by 2 raised to 3 by 3 factorial f triple dash of pi by 2, and so on. Now substituting these values in this equation, then we get here sin x f of pi by 2, that is 1, here 0 0 into anything 0, plus x minus pi by 2 by 2 factorial is 2, here minus 1, plus 3 times differentiation 0, then 4 times differentiation x minus pi by 2 whole square divided by 4 3 2, here value is 1, and so on. Then we get Taylor series of 1 sin x in powers of x minus pi by 4 is here negative sign, here 2 factorial plus x minus pi by 2 whole square divided by 4 factorial, here raised to 4, sorry, 0, f dash means here whole square, this term is here is 2 4, and so on. That is our equation 1. Now we have to find sin 91. To find sin 91 degree means that is the position of 91 degree, then convert 91 into radian form, then multiply with pi by 180. In scientific calculation, 91 into pi divided by 180, then we get 1.58825. Here pi by 2, then we get 1.57080. Then here we require x minus pi by 2, means x, that is 1.58825 minus pi by 2, that is 1.57080. Subtraction of this term, then we get 0.01745. Then substitute this value in this equation, and we get value of sin 91. Then sin x 1 minus 0.01745 whole square divided by 2 factorial is 2, 0.01745 raised to 4 by 4 factorial is 4 3 are 12 2 are 24, and so on. Here x equal to 91 degree. Then simplify this term, and we get sin 91, that is 0.99985. That is our approximate value. If you have any doubts regarding this topic, then feel free contact me. Thank you so much for watching me.